I'm going to attempt to do an application problem with you. This video may be a little bit challenging because the application problem is, of course, a word problem, and unfortunately, the application that I'm using to create the video, it doesn't really allow me to present text. I could write it out, but then you would be listening to 5 minutes of me clicking the full story out in front of you. So I'm going to go ahead and read it, and as I read it, I'm going to attempt to put together the picture and all the information. This does allow you the opportunity to kind of see how I model a problem, and then we will go through a couple in class as well. So the one that I'm going to go ahead and do, I have a rectangular playground that is 4 yards wide and 6 yards long. So I'm going to denote this playground with a black rectangle, and we know that this is 4 yards wide and 6 yards long. Okay. Then we also know that this playground is surrounded by a sidewalk of uniform width. So I will denote the sidewalk in purple. So we have a sidewalk that is going to basically fit around your playground. And basically when we are talking about a uniform width, we're basically saying no matter where you are, if you were to measure from the edge of the playground to the edge of the sidewalk, it will always have the same measurement. The problem does not tell you what that width is. We will actually be asked to find out what the width is. So since we don't know what the width is, we're just going to say that it is x, specifically yards wide. Okay. If I don't know, we hit it with a variable. So if the total area of the sidewalk is 56 yards squared, how wide is the sidewalk? So what I want you to note here is that what I'm about to kind of highlight in yellow, so the area of this full-blown sidewalk is going to be 56 square yards, excuse me. So let me just finish coloring in here. Okay, so the area, so what I've colored in yellow is 56 yards squared. So what I'm going to go ahead and do is I'm going to try to use all of the information that I have here. Okay. Sometimes, again, application problems may give you extraneous information, in other words, information that you can't use. But really what you want to do is try to digest all that information before you decide what to keep and what to throw out. So in this particular case, I'm going to go ahead and add up the area. So I'm going to say my full area here is going to be the area of the sidewalk, and I'm just going to abbreviate that as SW, plus the area of the playground. I'll denote that as PG. So I know that the area of the sidewalk is 56 square yards, and the area of the playground I can calculate. I know that the measurements for the area of the playground is 4 yards by 6 yards. So in order to find the area of the playground, we can just do 4 times 6. So I know that this is going to be plus 24. So that means that the full area, so sidewalk and playground, is going to come out to 80 square yards. Okay? All right. So now I know that that is what the full area is. So in other words, I'm going to kind of redraw what I have in red. I'm going to basically just combo this. So here is the outer perimeter of the sidewalk. And I need to kind of recreate this measurement. I know that, for example, the length of the playground is 6 yards squared. But I also know that I need to account for this extra width generated by the sidewalk. This is x, and this is also x, as you can kind of see how I have them denoted up here. So this means that the full length is going to be 6 plus 2 of those width measurements. Because again, in order to finish completing this, I need to include this width and this width. We can repeat the same kind of idea here. I know that the width of the playground is going to be 4 yards. But in order to actually expand it out all the way, I need to include the width of the sidewalk again. So here I need to include that x width and the x width. So the full width here is going to be 4 plus 2 of those width measurements again. So as you can see, I have the following. Let me pull this over a little bit so I have some more room. So I know that the length and the width, that is the formula for area. Length times width. So that means that the area of the full playground and sidewalk is going to be 80 times the length, which is 6 plus 2x, times the width, which is 4 plus 2x. Okay? So we do have a little bit more work to do. So in this situation, we will want to FOIL this out because remember, we want to go ahead and get this so that it is equal to 0. So if we FOIL this out, we would have 80 is equal to 24 plus 12x plus 8x plus 4x squared. And now we can subtract 80 from both sides. This gives us 0 is equal to, let's see here, if we do 24 minus 80, we get negative 56 plus 20x plus 4x squared. I'm really not a fan of how that is written right now, so I'm just going to rearrange everything. So let me scoot this up so I have some more room. I am going to have 0 is equal to positive 4x squared, because again, here's my first term, plus 20x, there's my second term, minus 56. Okay? So now I'm actually going to go ahead and solve this. Okay, now I've actually been able to construct the problem and bring it back to something that's based in just mathematical symbols. I brought it back to a problem that we were practicing in the very beginning of section 5.9. So here we have 0. Notice that each of the terms end with an even digit, a 4, a 0, and a 6. So that means that I can at least factor out a 2, but if we do note, each of them are actually divisible by 4, so I can pull a 4 out of each of these terms. This leaves me with an x squared plus 5x minus 14. So again, my main focus is going to center around what I have in this quantity. I can't really do anything with that 4 that I factored out, other than, since I pulled it out, it makes it a little bit easier for me to try to factor this. So let's go to the box method. We know that x squared will go on the top left, and the negative 14 will go on the bottom right. And let's see if we can break this apart. X squared can break into x and x. I do have a negative 14, so that tells me that one term will be positive and one term will be negative. And I also want my middle term to be positive, so that must mean that the larger of the two numbers that I'm going to try to break this into must become a positive value. So think about negative 14. What two numbers do you know multiply together to give you a 14? I mean, there is 1 times 14, but there is also 2 times 7. And I would say, given the fact that your x squared is just x and x, let's try working with the 7 and the 2. Since the 5x is positive in that middle term, I would say the 7, since it is bigger, should be the positive value. And then the 2 will be negative. Let's go ahead and check. So x times negative 2 gives you negative 2x. X times 7 gives you 7x. And then if we were to check this, if we were to add those, that is going to come out to a positive 5x, which is what we have, so that's great. Let's continue. So we can boil this down and say this is 0 is equal to 4 times the quantity x minus 2 times the quantity of x plus 7. Okay. Again, the fact that this is just a 4, if you were to say 4 is equal to 0, that doesn't make sense, so we have to throw this out as an option. That's not a possibility. Just focus on the binomials, because they have the variable that allows you to solve. So we would have x minus 2 is equal to 0, or x plus 7 is equal to 0. Add 2 to both sides in order to get x alone, to reveal that x could be equal to 2 yards. And then subtract 7 from both sides, and we're saying that x could be equal to negative 7 yards. So at that point, you should be kind of going, how can you have a negative measurement? And I would say, well, you can't in the real world. That doesn't make sense. So we have to automatically, given the context of the problem, say, nope, I can't use this. This is not a real option. So that does actually finally reveal the answer to you. X is equal to 2 yards. So the width of the sidewalk is 2 yards long. So if we were to go back up here, we're actually saying that the x value that we have here, this is 2 yards all the way around. Okay, so let me go ahead and do a check to drive this home, because we've done a lot of work. So sometimes when we go through solutions like these, the idea or the logic kind of gets buried. So let me go ahead and really quickly just draw a new drawing for you. So again, here is our playground. We said that this was 4 yards by 6 yards. And then we also had a sidewalk around it. So knowing that the width is uniform, and so the distance between the edge of the playground to the edge of the outer sidewalk is 2 yards, that means that this full value here is going to be 6 plus 2 yards plus 2 yards. So in other words, a total of 10 yards. Oops, sorry. Let me clean that up so that it makes more sense. So the length here is going to be 4 yards plus 2 yards plus 2 yards, or in other words, 8 yards. And then this is going to be the 6 yards plus 2 yards plus 2 yards, which is going to be equal to 10 yards. We had said that the area of just the sidewalk, so in other words, again, what I'm kind of coloring in red here, this was supposed to be 56 square yards. So let's make sure that that does actually happen here. So if we were to do the full area, so my full area is going to be equal to 8 times 10. So there's my 80 square yards. But I know that the area of the playground is going to be 4 times 6, which is 24 square yards. So if I remove this 24 yards from the 80, I should get that 56 yards, which was stated in the problem as being the area of the sidewalk, or again, what I've sketched in red. So if we do 80 square yards minus 24 square yards, I do get 56 square yards. So this is the area of the sidewalk. So I did do it correctly. The width should be 2 yards. I hope that this was helpful. Feel free to watch through the video one more time. Make sure that it's kind of piecing together. This may be one that it will be helpful to watch through a couple times, sketch along with it, take some notes for yourself. You guys are brilliant, so I think that you will definitely glom onto this and feel very prepared for the next class. All right, thank you.